You walk into a temple in Alexandria 2,000 years ago. A coin drops into a bronze slot. Inside the box, a lever tips, a valve opens, and a perfectly measured splash of holy water pours into your hands. No priest required. It is a fully automated vending machine, operating before the calendar even reached the year 1. The ancient world had central heating, mechanical robots, and shopping malls. They even achieved mass production. These Roman clay lamps were not shaped by hand, one by one. They were pressed into molds, identical to thousands of their siblings, creating standardized consumer goods that were shipped across an entire empire. In southern France, the Romans built the Barbagal complex. 16 water wheels turned in a coordinated descending sequence to grind grain. Material flowed continuously from top to bottom. It was a true factory, processing enough flour to feed thousands of people every single day. The physical evidence is undeniable. The mechanical pieces for an industrial revolution were sitting right there on the table. They had the gears, the water power, the assembly lines, and the engineering genius. So why did the world wait another 17 centuries to actually build the machine age? We are taught to view history as a staircase. At the bottom, shivering cavemen. A few steps up, the Greeks and Romans. And at the very top, us, with our steam engines and factories. But the physical ruins force us to shatter that picture entirely. Historian Peter Kriger points out that the ancients were not failed rough drafts of modern humans. They didn't lack intelligence, scientific observation, or technical skill. The problem is that we keep grading them on a test they never signed up to take. They possessed the technology. What they lacked was the specific economic pressure that forces a society to reorganize its entire way of life around building machines. Technological progress does not march on an inevitable upward path. It reacts to economic incentives. The real mystery of antiquity is not why they couldn't industrialize. It is why they didn't want to. You only invent a machine to save labor if human labor is a problem you actually need to solve. If workers are scarce or expensive, an engineer who builds a device to do the work of 10 people is rewarded with a fortune. The ancient world didn't face that pressure. They already owned a device that could walk over rough terrain, judge which crops were ripe, learn new instructions on the fly, and repair its own minor injuries. That highly adaptable, self-repairing, general-purpose machine was the human being. The entire ancient economy ran on an endless supply of cheap and frequently unfree labor. People were the literal cogs in the mechanism of their industry. This creates a brutal economic arithmetic. If you can buy, own, and work a human being for the cost of their daily food, there is absolutely no reason to spend a fortune developing a complex mechanical substitute. A labor-saving machine in Rome or Alexandria was an oddity, not a treasure. Inventors left their designs small because, in a world of inexpensive human hands, they were offering a solution society simply refused to pay for. There was also a hard physical limit. Before coal and oil, energy came from muscle, wind, and water. As this map shows, these power sources were stubbornly tied to specific geographic locations. You cannot move a river. To build a global machine age, you need a concentrated, portable power source, deployable anywhere on demand. But the deepest barrier was cultural. We suffer from the yardstick problem, measuring the ancients by how closely they match our modern obsession with manufacturing efficiency. Every civilization builds exactly what it values most. The ancients poured their genius into public magnificence, the glory of the city, and the production of sheer wonder. When an engineer like Heron of Alexandria built a working steam engine, he didn't use it to haul grain. He used it to spin a metal sphere to dazzle dinner guests. He built temple doors that opened automatically to overall worshippers. Society rewarded awe, so awe is what the engineers delivered. They lacked the concentrated fuel, and they lacked the cultural desire to mechanize their labor. Without those two sparks, the scattered kindling of an ancient industrial revolution remained permanently unlit. We tend to view the modern industrial revolution as human destiny. In reality, it was a freak economic anomaly. It required a specific alignment that never happened before, a pressing scarcity of labor, dense fossil fuels, and a culture that prized output. This massive mechanical complex only makes sense when coal is abundant and hands are scarce.
The ancients weren't trying to build steam engines and failing. They were succeeding brilliantly at their own goals. They engineered the vast, unsupported expanse of the Pantheon Dome because they valued the eternal spectacle of public life.
For 10,000 years, the absence of a machine age was not a failure or a delay. It was simply the normal, default condition of human civilization operating under the economic realities of the time. Which brings us to the sharpest reflection in the historical mirror. For the first time in human history, the biological human being is losing its status as the supreme, cheapest machine. We are finally crossing the exact economic threshold the ancients never reached. The arithmetic is tipping. Digital and mechanical servants are now becoming faster, more adaptable, and cheaper than the people they are designed to replace. If history proves that every civilization ultimately builds exactly what it values, it leaves us with a quiet, uncomfortable question. 1,000 years from now, what will future historians say we chose to build? History is a ledger of our priorities. The technologies we choose to scale and the human roles we choose to automate will reveal to the future exactly what our society truly cared about.